So if you look at problem 5, as we demonstrated in class, we have, first of all, if you look carefully, 2 rectangles, one outside, one inside, but you got to envision this as like one whole piece, and then this white rectangle inside is where you cut out, right? And so to demonstrate this, you got a piece of paper and you show that to us. But mathematically speaking, if you want to find the area, the shaded, which is this part only, what do you define first? Say it out loud, please. Okay, so you're telling me that you have to find the area of the big rectangle and the area of the small rectangle, and what do you do with those 2 areas? Yes, Isaiah. From the big one. Okay, so what I'm really asking you to do for this kind of problem is set up a structure for the problem. First of all, we talk about the area, so right away, just like any other problem, you should say, wait, the area, generally speaking, the area of rectangle is just length times width. We know that. And then you look back at the problem and say, wait, are the length and width given? Okay, even though they're not numbers, but they are given nonetheless. Is that correct? We have the length and width of the larger, so I'm going to use the uppercase for the larger and lowercase for the smaller. Okay, so wouldn't you say that this is the width of the larger rectangle, and this is the length of the larger rectangle? Okay, and for the smaller one, this would be the length of the smaller rectangle, and this would be the width of the smaller rectangle. It looks like a tooth. Yeah, it does.
No.
It looks like a little.
Oh, wait. Okay, moving on. Alright, that's floss.
No, that looks nasty.
Okay, moving on.
It's in that video.
So, listen. So for the area,
I'm gonna report that.
for the area of the big rectangle, what would you do?
Take it away.
What would you do? How do you find it? What do you plug in?
I'll report that.
Which is 3x plus 2 times 4x.
Hey, is it recording?
It is. Okay, moving on. And for what about the area of the smaller rectangle? What is the area of the smaller rectangle? So I'm just going to label this as big rectangle, and this is the small one.
Whoa.
So for the small one, what would you multiply? What's the length? What's the width?
2. 3.
2 by 2.
Say it.
2x.
2x times 3x. Okay, let's simplify this. What is 2x times 3x?
6x.
Okay, now
6 squared.
wait.
6x squared.
I love how you said 6x because it gives us a purpose to review too. Because think about this. When you're saying x times x equal to x, give yourself a little example. Let's say that x is 2. Are you telling me that x times x, which is 2 times 2, is 2?
No.
See? It doesn't make any sense for you to say now x times x is x, isn't it? What you need to say is, wait, didn't we know how to take x times x and write it as a power, which is x what? Squared. So always give yourself a little example if you think, wait, this doesn't make sense. Okay? So we know now that x times x is not x. It's actually, x squared. Okay. As soon as I can get rid of this. Sometimes it gets dirty. Okay, moving on. 6x squared will be the area of a small rectangle. Well, let's do the one for the big rectangle. What strategy did we use last time to do this? Distribute. So we'll do that. What is that going to give us?
12x squared.
12x squared
Plus 8x.
plus 8x. So we have the area of the large rectangle. We have the area of the small rectangle. What do you do with the 2? Subtract. Okay, so you're saying I'm going to set up a subtraction problem. Fine. Subtract what and what? What from what?
The small from the large.
The small from the large. So the large is 12x squared plus 8x, and the small is 6x squared. And look at this. Does this represent the large? Does this represent the small? Okay, so there we have it. We have the large rectangle subtract the small rectangle to give us what the shaded part is all about. But for us to do this, what's the next step? What are we looking for now? Well, notice that we don't know what x is, so the best thing we can do is what? What is that? Combine like terms. Any like terms? What?
12x, 6x.
12x squared and?
6x squared.
Well, no. Think carefully. What did I say last time? Now, when you circle what? The sign in front as well. Very good. Don't forget about that. You see it? When you circle the sign in front as well.
72.
So now when you said, what is 12x squared minus 6x squared?
Negative 72x.
Wait. 12x squared minus 6x squared is negative 72x? 6x squared. Okay, and of course, plus 8x. And this is how we have our area, the shaded part. So very simple step, right?
Wait, what'd you say? The shaded?
Yes.
Oh, this is
What's the shaded part?
What? You have an issue with this?
No, because it sounded like you said something else.
No, of course not. All right.
Oh, I do understand it.
Okay. Moving on then. All right. So you understand the basic structure. Okay. Like that.
Yeah.
So this is what we call a preview of the donut problem that we're going to be doing later on in the week, which is on Friday. Pretty similar stuff. So if you kind of notice, this is like a rectangular donut kind of deal. Kind of like that. So the donut problem that you're going to be doing towards the end of the week, it's going to resemble that. We have to have a cutout. We got to find the area of the whole thing first, area of this small thing inside, and we just subtract it. So that's just a general strategy to do donut problems. All right. So as we move on to this next problem here, take a look at this one. Imagine I have the following. Okay, take a look at that one. Clearly, I have what? What is this called?
Inequality?
Inequality,
No, equality.
which is called an
Equation.
equation. We have the equation, fine. But if I ask you to solve this, what would you do? Distribute. Okay, fine. So the general strategy is distribute. Okay. All right. If you distribute, what are you gonna have? Negative 3x plus 24, negative 5x plus 10. Do we also distribute this or not?
No.
Why?
Because it's not in the parentheses.
It's not inside of parentheses, so please do not ever try to do that. I'm reminding you, friendly reminder. Okay, so that will stay as is. And so, do you remember the strategy to solve this kind of problem? What do you do from here? Combine like terms, but the easiest way to recognize like term is by doing what? Circle, box and circle. So I'm going to go ahead and circle all the variables and box all the numbers because these I only have two types, numbers and variables, right? There it is. So what would you like to move? Okay, the circle from left to right or right to left? Right to left. You said right to left. Or which one is the easiest move really? Meaning I want to do it so that I have the minimum amount of move.
Left to right.
Left to right. So I'm going to go ahead and move this one over, right? How do I move that over? Okay, add the 5x. That'll be gone, right? Now what? Good, I'm going to move the box over, subtract 24, subtract 24. So I hope you realize by now that when I circle and box or triangle, whatever, when I move that, I either add or subtract over. Have you ever seen me circle and then start dividing, multiplying over? No, okay? So that is like a strategy for you too, that when you start doing something like that, circle or box, you are either adding or subtracting to move them around, okay? All right, so let's combine like terms. What is negative 3x plus 5x? 2x. That's on the left-hand side. Moving on to these boxes right here, I have 10, take away 8, 2 minus 24. Negative 22. Okay, and last step, what do you do here? Divided by 2, and x is negative 11, and therefore that's my answer. Any questions? Okay, so what did we use? Distributive property, combining like terms, and some basic strategy to solve an equation. That's it. Okay? So I give you a complex problem. Yes, Inessa.
Oh, that's a 2, never mind.
Yes. Yeah, it's a 2. I'm sorry. let me make. Oh.
I guess not.
Okay, the light doesn't. Okay,
That's like what
my eraser doesn't work anymore. I have to use this one to erase.
Blow the cartoon.
Oh.
Hey, it looks like fish. It looks like fish.
Okay, moving on. Here's your question.
You know